2,100 feet of metal, 17 miles out in the desert, in an austere portion of Holloman Air Force Base, the magnetically levitated sled system is where man and machine come together to achieve the unthinkable. On March 4th, 2016, the 846 Test Squadron made history when they broke the world land speed record on a magnetically levitated sled system twice in 1 week.
3, 2, 1, 0, fire.
So we have a magnetically levitated sled where we use a very cold liquid helium to essentially levitate the sled via superconducting magnets, and it's a developmental system. So we went ahead and launched that sled for the first time successfully in a couple years. So in the past we have gone 513 miles per hour. Prior to that, which was a couple years ago, we went 510. So the test today was significantly faster than any test that we have previously done. It was great. Yeah, I was really proud of the team. They did a lot of work, and they did an awesome job.
The test on March 4th holds a current record with 633 miles per hour. But just 2 days before, the 846 had a record-breaking launch, with their sled clocking in at 513 miles per hour. Reporting from Holloman Air Force Base, New Mexico, I'm Senior Airman Brianne Sachs.
5, 4, 3, 2, 1, 0, fire.
There's like a layer, kind of like a good thermos would be. Right up here. You can actually see the remnants of some of the screen up here. But that's the sort of, you said you were out here before. Yeah, I know it's actually.
So we launched our magnetic levitation sled from launch point, but we did achieve staging of the motors, which is the first time. Wednesday was the first time we did it, and we did it again today. And we also achieved the fastest speed on a magnetic levitation sled. It was 928 feet per second. I was the project manager, so I kind of essentially gathered everybody in the team together, put all the paperwork together, all the safety stuff together, and essentially gathered everything, the personnel and the paperwork needed to put a test together and make it happen on launch day. It was nerve-wracking in here, you know, while we were all looking to make sure that the magnets were working the way they're supposed to work. But once it went on Wednesday, you know, we saw it go, which was the first time, I think, in 3 years. 2013 was the last time we launched a successful mission. So Wednesday it felt awesome. Today it felt even better. It's a few months of preparation. So we've got different shops at the track. We've got the sled launch guys who are the ones who are doing the work out here in the rail. bringing the sled out here, putting the motors on, setting up the motors, and we've got instrumentation crew who take care of all the instrumentation that goes on the sled, and then they connect all of that to here, the mobile launch that kind of controls everything that's connected to the sled. We've got the project management flight, so I'm part of it, and I get help from them as well. We have the data engineers who are out here taking pictures, and they're also the ones that put together all the data and the data reports and kind of tell us what happened. And so we kind of bring everybody together and make this work. We have tons of meetings to make sure that everything is going well. Another big achievement that I didn't talk about when you asked me that question, one of the reasons we were not successful in the past was because our procedures for this, it's a very complicated system, as you saw, weren't up to par, and so we all worked really hard to get those procedures very clear, step by step, and everything seemed to go very smooth. Today, in this launch, we broke the world record on land speed on the magnetic levitation rail. It was 928 feet per second.
Launched that sled for the first time successfully in a couple years, and got some good data as a result of doing that. So probably the best way to describe it, if you look at the other rail that we're really well known for, it's very, very fast, but it's also a really rough ride for systems that go down that rail. There's a lot of vibration. So the Maglev system gives us the ability to test systems without as much vibration. So if you have sensitive components that are part of a weapon system and you want to test them in a realistic environment, a system like this allows us to do that. So that's why we want to develop it, so that we can test those types of components in a more operationally relevant environment. We've had the assistance of the contractor that helped us build this system for previous tests. A couple years ago, we basically decided that we thought we were ready to do it on our own, and we tried a few times. Unfortunately, we had some issues with some of our procedures and understanding how to operate some of the specialized hardware that you have to use when you're dealing with cryogenic type elements. When you have liquid helium and things like that, it becomes difficult. So we got the contractor back to give us a little bit more education, and we went ahead and executed a mission on Wednesday, and then we executed one today completely on our own. The one on Wednesday we had their help, but today we were completely solo. So it was great. Yeah, I was really proud of the team. They did a lot of work to try to really improve our procedures and try to understand how the system works, and they did an awesome job. So it was really cool to see it go. This one was a little bit different because we knew we had to really take a step back and try to understand it better than we thought we did before. So in this case, it took us about 6 months or so to really, again, take a step back and look at our procedures and refine those, and then work with the contractor again to make sure we were ready to go. So that's a little longer than normal. I would say typically now that we're ready to go, we'd probably have a month or two of preparation time just to make sure the system was ready to go. But yeah, so 6 months this time, but normally quite a bit shorter than that. So for the Maglev system, what we had planned to do after this test was refine the design of the sled itself. So this was a fairly heavy design, so we want to look at some lighter materials and continue to see what sort of capability we can get out of the system in terms of the speeds that we're capable of going, so that we can, again, measure those vibration environments at various speeds and understand what the system is really capable of as we continue to go faster and faster. That's, I think, one of the neatest things about being part of the test track is the specialized expertise that we have here, and that's what we tell everybody that comes out for a tour. Is it's so cool, all the different elements that make up the track. You have experts that know how to run a program from the top down. You have the guys that are out in the shops, know how to build sleds. You have the engineers that know how to design sleds. You have the engineers and the technicians that instrument the sleds, and it's just it's a great team effort. It's really neat to see. So I just feel lucky to have the opportunity to be here when we're doing testing like this. It's really an honor to be a part of it, and hopefully, even after I'm gone, they'll continue to do great work, and I'm sure they will, and continue to develop new and better capabilities in the future. So yeah, today was the fastest test we've ever done with Maglev, and we went 633 miles per hour. So in the past, we have gone, actually Wednesday we went 513 miles per hour, and prior to that, which was a couple years ago, we went 510. So the test today was significantly faster than any test that we have previously done. So.